Hello and welcome. This is the presentation for Computational Thinking, the BSc programme available at the Department of Computer Science at Maynooth University. My name is Dr. Joe Timoney and I'm Head of Department at Computer Science. So maybe the first question most people would ask is, what is computational thinking? Well, computational thinking is the process of approaching a problem in a systematic manner. So by first examining the problem, you can imagine the solution. And then, if you can visualize how the problem can be transformed into a numerical representation, you can solve it using a computer program that you could devise. Thus, computational thinking involves combining human creativity with the power of computer to solve problems. This could mean applying heuristics, such as experience-based techniques, to find answers in the presence of uncertainty, reformulating difficult questions by making connections with ones that have already been answered, or by modelling problems to break them down into smaller pieces. Thinking computationally is not just programming, it's not even thinking like a computer. But computers, they can't think. A programmer tells a computer what to do and how to do it. But computational thinking enables you to work out exactly what to tell the computer to do through the programmer. So there's 4 cornerstones in computational thinking. The first part is decomposition. So you use logic to break down a complex problem or system into smaller, more manageable parts. Then you use pattern recognition. You look for similarities among and within the problems that you see. Then you move to abstraction, where you focus on the important information only and you ignore all the irrelevant detail. And then lastly, it's all about algorithms. So you develop a step-by-step solution to the problem or the rules to follow to solve that problem. So an understanding of computational thinking will give you a foundation for solving problems that have a real-world social impact. Many quantitative and data-centric problems need the skills of computational thinking to be understood correctly. So the Bachelor of Science in Computational Thinking is ideal for students that have a strong mathematical ability, a flair for analytical reasoning, and who enjoy devising clever solutions to problems. So the degree unites the 3 fields of computer science, mathematics, and philosophy, and it's shared across the 3 departments. Students of computational thinking begin with programming computer science. They take the mathematical foundations as well as learning the meaning of logic and argument from philosophy. Then, throughout the degree, they'll acquire hands-on programming skills, advanced problem-solving techniques, and learn to think logically and analytically when approaching complex problems. So to do computational thinking, you can either take a 3-year BSc degree, or you can do a 4-year BSc International degree, where you have 1 year study abroad that normally happens in your 3rd year. So to give an outline of the programme, if you come into first year, you're going to have 6 modules in mathematics, 4 modules in computer science and 2 modules in philosophy. In your 2nd year, you will have 4 modules in mathematics, 6 modules in computer science and 2 modules in philosophy. The year 3 would be your optional year abroad, and that would be helped with the International Office to help you find a place in a university outside Ireland. Many students opt to take the Erasmus scheme and maybe go to somewhere like the University of Pompeu Fabra in Barcelona. Others have gone to Toronto in Canada. Then, in the final year of the BSc, you take 6 credits of mathematics, 4 of computer science and 2 of philosophy. The entry requirement to the programme is a H2 in mathematics. In the first year, the type of mathematics modules that you'll take will be like integration, finite mathematics, analysis, multivariable calculus, algebra, and Euclidean geometry. In computer science, you take the fundamental courses that help you with programming, such as Algorithms and Data Structures 1 and 2, Introduction to Computational Thinking, and then Operating Systems, Communications and Concurrency. And then philosophy, you look at Introduction to Philosophy and the Theory of Mind and Logical Thinking. In our 2nd year, you have 4 credits or 4 modules in mathematics, and they involve real analysis, metric spaces, which is essentially real analysis 2, and you have complex analysis 1 and group theory. In computer science, you'll be looking at programming languages and compilers, theory of computation, software verification, computational complexity, and numerical computation. And finally, then you have computational epistemology. So that's a mixture of the practical skills of computer science with some of the theories that underlie computer science and are very important for understanding how programs are made, how they work, and how they can solve problems in space of time. In philosophy department, then you do the philosophy of natural science and you do epistemology. In then year 3, if you're taking the final year in Maynooth, or if it would be a year 4 if you've gone on a year abroad, you have to do 6 credits of mathematics through a particular set of choices there. And then you have lots of electives that you take between the various departments. There's a wide number of electives in computer science that involve modules such as signal processing, machine learning, computer vision, cryptography, robotics and automation. In philosophy, you can take modules in post-Kantian, German idealism, pluralism, analytical philosophy. In mathematics, you have a number of compulsory modules, and then you can choose from a number of electives that involve things like data analysis, statistical computing, probability, inference, and modelling. If you want to find out more about details in particular modules, you can go to our course finder page on the Maynooth University website. In this presentation, if you press Control-click, you will open a link on a web page and you will see it there in front of you. Just to give you a little bit of information on 2 students that are currently in the programme. So we have Owen Davey, who's in the class of 2020. He came first in the International Olympiad in Informatics for Ireland in 2016. He came first place in the Irish Collegiate Programming Competition in 2016 and second place in 2019. He took first place in the All-Ireland Programming Olympiad in 2016. He took third place worldwide in the Hack MIT entry competition and 13th place worldwide in the same competition in 2019. He was the third in Europe and the 53rd worldwide in the IEEE Extreme Programming Competition in 2019. He took first place in Ireland in the Hashcode Extended Round in 2018. He was in the top 10 ICPC ECNA region representing the University of Toronto in 2018, where he had done his study abroad. He's first in Ireland on Catus.com, and he came second place in the AIB Data Hack in 2017. Mathieu is also in the class of 2020. He had 2 IOI appearances for Ireland in 2012 and 2013. He came first place in the All-Ireland Programming Olympiad in 2012. He came third place in the Irish Collegiate Programme Competition in 2018. He's in the top 100 in the world in the IEEE Extreme Programming Competition in 2018. He's done 2 Google internships as a compiler researcher in Paris and a Google Chrome V8 researcher in London. And he was involved in the Coder Dojo Coolest projects when he was in secondary school. Just to let you know, the computational thinking can play a role in many, many disciplines. The volume and rate at which scientists and engineers are now collecting and producing data through instruments, experiments, simulations and crowdsourcing are demanding advances in data analytics, data storage and retrieval, as well as data visualization. And the complexity of the multidimensional systems that science and engineers want to model and analyze requires new computational abstractions. Active areas of study include algorithmic medicine, computational economics, computational finance, computational law, computational social science, digital archaeology, digital arts, digital humanities, digital journalism. You have, let's say, legal informatics, which mechanizes legal reasoning. Computational social science is about leveraging the power of big data, computer simulations, and social networks to understand social phenomena and individual behavior. Computational psychology is a discipline lying on the border between artificial intelligence and psychology. It's concerned with building computer models of human cognitive processes, and it's based on an analogy between the human mind and computer programs. Other areas in science include chemistry, biology, physics. So basically, wherever you have data that needs to be understood, you have a necessity for computational thinking. Considering the career and earnings prospects, the average salaries for the computing profession, as shown by the New Scientist in a recent survey, showed the computer sciences were way at the top, above engineering, earth scientists, physics, medical, chemistry, and environmental and biosciences. The sort of careers that our graduates take are in companies that are leading IT multinationals in Ireland, such as SAP, SIG, Intel, Ericsson's, Amazon's and IBM. Last year, the university had a placement fair. In November 2019, there was over 30 companies, and this was held on campus. Companies such as the Central Bank, Deloitte, Enterprise Ireland, ESB, Fidelity Investments, Glanbia, KPMG, the Revenue Commissioners, Takeda. They all came and they were searching for our graduates and hoping to get them in on graduate programmes. If you have any further inquiries about the course, please contact the coordinator, Dr. Phil Maguire, at pmaguire@cs.nuim.ie, or you can contact myself, Joseph Timoney, at joseph.timoney@mu.ie. Thank you.